Assalamualaikum and a good day to everyone, especially to my supervisor and my panels. My name is Mohd Syakir bin Sufi, and today I will continue to present my final year project entitled Development of Assistive Device for Hip Abductor Adductor Equipment for Neurological and Spinal Cord Injury People. This project is supervised by Puan Ruzy Haryati binti Hambali. This is the outline for my presentation where I will be explained briefly for introduction, problem statements, objective and scopes, literature review, methodology, just to recap from FYP 1, and for this FYP 2, results and discussion were obtained. Lastly is the conclusion. As I recap my FYP 1, my project basically will focus on paraplegic who suffers spinal cord injury at lumbar vertebrae that involve lumbar nerve of level L1 to L5. Injuries generally result in some loss of function in the hips and legs. To improve the quality of patient's life and also to be able to perform normal daily tasks, the development of an assistive device for hip abductor adductor is a major help for the patients. These are the difference of abduction and adduction, where abduction is any motion of the limbs or other body parts that pulls away from the midline of the body, while adduction is the movement of a body part towards the body's midline. Moving on to the problem statement. For your information, these are all the category of spinal cord injury which divided into 4 categories: cervical vertebrae, thoracic vertebrae, lumbar vertebrae, and sacrum. And my project focus is in lumbar vertebrae category, which involve leg muscles that also divided into 4 levels. The lumbar spine is the third region of the vertebral column, located in the lower back between the thoracic and sacral vertebral segments. It is made up of 5 distinct vertebrae, which are the largest of the vertebral column. This supports the lumbar spine in its main function as a weight-bearing structure. These lumbar vertebrae, or lumbar bones, contain spinal cord tissue and nerve which control communication between the brain and the legs. Damage to the lumbar spinal cord subsequently affects the hips and groin area and may impact the lower abdominal muscle and thigh flexion as well. With the existing assistive device, the device is still not achieving the level of independency required for the paraplegic, and that is why this research is happening. Next is the objective and scopes for this project. For the first objective is to determine issue of neurological and spinal cord injury people, strengthen the target muscle and stabilize the hip according to the human factors engineering and material selection. The scopes: conduct a brainstorming and questionnaire on paraplegic, also observation on the use of existing assistive device. The second one is to develop an assistive device that's suitable for the spinal cord injury of hip patient to all angle, which is in low cost and high profitability. The scope is conduct engineering analysis to determine stress, displacement and strain using pure matrix selection, construct the design and drawing using SolidWorks software, and the selection of material using CES EduPack software, also manufacturing process to fabricate the prototype. The last objective is to analyze and validate the usability of the product development. The scope is conduct manual muscle testing MMT and electromyography EMG test to validate the functionality of the assistive device and comparing the muscle activity with or without the device. Moving on to the literature review, this research has been narrowed on the research about how the assistive device promotes recovery of paraplegic, also the clinical uses of EMG and MMT. According to Masni in 2009, assistive device help the patient to prevent impairment, at the same time promote recovery and enhance self-independence. According to Tulberg and Maguire Jr. in 2010, flexion and extension in the lumbar spine is the product of a combination of rotation and translation in the sagittal plane between each vertebrae. According to Netter and Frank in 2001, hip abduction occurs when the femur moves outward to the side, as in taking the thighs apart. Hip adduction occurs when the femur moves back to the midline. According to Hussain and Yassin in 2006, EMG is used as a diagnostic tool for identifying neuromuscular diseases or as a research tool for studying kinesiology and disorders of motor control. And lastly, according to Sims and Judith in 2008, MMT may be suboptimal functioning of the tested target muscle that can be used as an indicator muscle for other physiological testing. Here is the detail of the relationship between objective and methodology. During my FYP 1, Objective 1 and Objective 2 were achieved as they were to determine the issues of spinal cord injury people, strengthen the target muscle by conducting brainstorming and questionnaire method. As for Objective 2, which is to develop the assistive device, engineering analysis such as pure matrix design, SolidWorks software and CES EduPack software, also fabrication process were conducted. And lastly, for the FYP 2, I have achieved the Objective 3, which are to validate and test the functionality of the prototype of assistive device using manual muscle testing MMT and electromyography test EMG. Moving on to the result and discussion, as for Objective 1, this is the result of the questionnaire that have been conducted in FYP 1. The users prefer to have strong and low-cost assistive device, following with reliable, as they need a device that is in good quality and can be used for a longer time. Portable is the least preference for the mostly users, as they know and already specified that this device can only be used for allocating and specific time, during physiology session, for example. Next, to achieve objective 2, I divided them into two, which are engineering analysis that have been used for design purpose and manufacturing process for fabrication. Figure here shows the outline and summary of the analysis and process conducted. Pure matrix selection is being used to determine the ideal design selection according to the criteria as listed in the figure. 5 designs were proposed, and using this analysis, the ideal design can be narrowed down. According to the rank order, Concept Design 5 has been chosen as the final design that meets all the criteria and requirements of the users. Engineering analysis. Next is by using SolidWorks software, the ideal design from previous analysis, which is Concept Design 5, can be drawn, and in the same software, Finite Element Analysis or FEA can be obtained. This analysis allows to locate potential problems in a design, including areas of tension and weak spot, as stated, stress, displacement, and strain. By using CES EduPack software, material selection analysis can be conducted. These are all the steps needed to go through to select the materials of the component. Through this analysis, low alloy steel was selected since it has good corrosion resistance, high strength, and adequate fracture toughness. With these properties, it can ensure that low alloy steel can be the perfect material for the fabrication of the parts and will not fail out in the field. Last but not least, for the objective 2, the development of the assistive device is the prototype that have been fabricated. Figure here shows the final product from front, side, and rear view. The dimensions of the product is based on the standard Malaysian size, which should be no problem for the Malaysian users, men and women. The analysis needs to be measured again with anthropometry analysis later on, if there is demand and request from other countries' users. On the left is the picture of the existing product, and on the right is the video of the development of the assistive device and on how the device works. Both of the legs will swing to the side, and after that will return to its original position. A new feature was added to add independency value, which is by adding a lever so that the users can operate the device by themselves, compared to the existing product that needed a physiotherapist to help. As for objective 3, validation has been conducted using manual muscle testing or MMT. There is a method of evaluating muscle strength. Figure above shows a scoring of 3% underwent the test. With MMT, patients are instructed to hold the corresponding limb or appropriate body part to be tested at a specific point in its available range of motion, working against gravity, or while the practitioner provides opposing manual resistance to determine the grade to assign the muscle. Here is the example of raw data from EMG analysis. It shows the muscle activity with and without the assistive device. The green line represents muscle activity with the device, and the blue line represents the muscle activity without the device. While figure on the right indicates an example of raw data that has been extracted from EMG and exported to Excel. Through this data, histogram can be produced in order to validate the efficiency of the assistive device. These three figures above shows a histogram of certain muscles to compare the activities with or without the aid of the assistive device using EMG analysis. First histogram shows the average RMS value of the gluteal muscle with and without device of a normal person. With RMS value as shown in the histogram, after calculation, it is proven that the device can regain muscle activity by 74%. Moving on to the second histogram, the data shows the average RMS value of pectineus muscle with and without device of a normal person. With RMS value shown above, after calculation, it is proven that the device can regain muscle activity by 90.47%. Lastly, the third histogram shows the average RMS value of tensor fasciae latae muscle with and without device of a normal person. With RMS value as shown in the histogram, after calculation, it is proven that the device can regain muscle activity by 90.62%. As a result, based on the three muscles involved with and without device, it shows that with the device, a person can regain their muscle activity, which means that the device can help them focus on the muscle contraction in order to maximize efficiency and to be able to use their leg as they used to. This is said because every muscle activity increases with average of 83.03% with the help of the device. As a conclusion, the usage of this assistive device has proven to be a contribution for the paraplegic. It is also portable and small tool that can be easily moved around and save space in the physiotherapy session that benefits and ease the physiotherapy workers and also the paraplegic during their physiotherapy session. Lastly, all the objectives are fulfilled, which is to develop an assistive device that is low cost and reliable for the users that lead to the independency. The vision of this study is to be a benchmark in order to develop better assistive device in the future to help paraplegic improving their quality of life. However, there are some recommendations for those who probably want to continue this research. First, do additional analysis on the anthropometry, be universal assistive device for paraplegic. Next, add on more features that leads to the comfortability of the paraplegic. And lastly, improve the design and maintain the low risk value. During the research, I found the decision making of the most suitable design is a good for sustainable decision and development because it is a dynamic approach. And the most important is the profit gain without polluting the environment and surrounding, and also the uses of biodegradable material. And that's all for my presentation. I hope you guys enjoy and get the idea of the project. Thank you.